Friends, I am Dr. P.M. Patil. Today we'll going to see the light dimmer circuit. This light dimmer circuit you can use for controlling the intensity of lamp. The circuit is also referred as AC regulator. Here AC supply is connected, lamp load is there, and a TRIAC is used. TRIAC is nothing but bidirectional device which are having three terminals, the MT1, MT2 and gate. So even if you will connect two anti-parallel SCRs, you can form a TRIAC. So a DIAC is used and a RC charging circuit. So here a variable resistance can vary the charging time of this capacitor. So whenever capacitor will reach to a particular breakover voltage of this DIAC, then this DIAC will break and the TRIAC will be fired and current will flow by this path. So we'll see the operation in detail now. Now during positive half cycle, this is the phase which will become positive with respect to neutral. So this positive terminal will be connected to this MT1 of this TRIAC, and negative terminal will be connected to MT2 terminal of this TRIAC, so that this will be in forward blocking state. So whenever we'll fire this, it will conduct. So a small amount of current will flow through this resistance and capacitance to charge this capacitor with positive to this upper plate and negative to this lower plate. Whenever this voltage on this capacitor will become equal to breakover voltage of this DIAC will break. It's a bidirectional device. So DIAC will break and this capacitor voltage will be connected to gate of this TRIAC, and this TRIAC will turn on at that particular time, and a heavy load current will flow through this lamp by this path, phase through lamp load, MT1 through TRIAC, MT2 back to neutral of this supply. During negative half cycle, this phase will become negative and neutral will become positive. So current will flow by this path, a minor current will flow through this path, and this capacitor will be charged with positive to the lower plate and negative to the upper plate. Whenever this capacitor will charge to breakover voltage of this DIAC, since DIAC is a bidirectional device, it will conduct and this voltage will be applied to gate of this TRIAC, and this TRIAC will turn on and current will flow through the load by this path from neutral of this supply through MT2 through TRIAC, MT1 and through this load back to phase. So this will continue its conduction. If we'll see the waveforms, this is the supply voltage waveform which is sinusoidal one. Now at this particular instant alpha, the voltage on this capacitor has become equal to breakover voltage of this DIAC, and DIAC conducts and simultaneously the voltage will be applied to gate of this TRIAC and TRIAC conducts. So the load voltage waveform will be same as that of supply voltage waveform from alpha to pi. Again at pi, this TRIAC will go off and this capacitor will charge in reverse direction. Whenever this capacitor voltage will become equal to breakover voltage of this DIAC, it happens at pi plus alpha. So at pi plus alpha, this TRIAC will turn on and a negative current will flow through this load, and that is this voltage waveform. Load voltage waveform will follow the same as supply voltage till 2 pi. If we'll see, divide this operation in different modes. This is the first mode of operation, during which this capacitor is getting charged through this resistance R with this polarity positive and negative. Whenever this voltage will be equal to breakover voltage of this DIAC, it will conduct and load current will flow through TRIAC by this path. So this is mode 2. Then at pi, this mode will turn off and mode 3 will start, in which negative current will flow through this path and capacitor will charge with this plate as positive and this as negative. Whenever this voltage will become equal to breakover voltage of this diac will turn on. This means this capacitor voltage will be applied to gate of this triac and turning it on, and reverse current will flow through this load. So this is the mode 4. Thank you.